Hi, meet Namnar Shammamah, but you can call me Sham. I'm very excited and terrified to be here today. This is my first time in Sweden, and actually it's my first PyCon ever. So that's pretty crazy. So before we continue, who in this room knows about Plotly? Okay, that's great. So that's my workplace. I'm a software engineer at Plotly. And before I was doing this, I was actually studying physics. So today's talk is going to be about time and energy. So a couple of years ago, I was still doing my undergrad, and it was final season. So I had to sort of restructure how I spent my time. And I had to make sure that I was using my time as efficiently as possible in order to get as much studying done as possible. So obviously, I decided that the best way to spend my time was cleaning my entire kitchen, crocheting mittens, even though it was basically summer, and going really deep into dream interpretation. Side note, all of my dreams were about failing my exams, so not a lot of interpretation needed there. And one of my favorite productive but unproductive activities of all time is Wikipedia surfing. So what this is you go to a random Wikipedia article, and then you find a random link in that random Wikipedia article, and you click on it, and that takes you to a different article. And you just repeat this over and over until it's 1 a.m., and then you have to go to bed. And even though you haven't done anything super useful, you're still learning things. So that sort of takes away some of the guilt. Anyway, so I was doing this, and eventually I came across this article on lean manufacturing. And this is actually one of the only ones that I finished and that I read through all the way to the end. So basically, it's an idea that came about during the Industrial Revolution. And it's all about constantly evaluating the way that you manufacture products and trying to eliminate anything that could be introducing waste into those processes. So basically what it's about is it's emphasizing what's important by getting rid of everything that isn't. So I decided maybe it was important for me to go to bed and then study the next morning, so I did that. And then by some miracle, I actually managed to pull through exams. But even as I entered the summer, I couldn't get this idea of lean manufacturing out of my head. And it's actually going to show up later in this talk, so I hope that you all keep it in the back of your minds as well. So you might be wondering why I told you this story. This is PyCon, and my story doesn't have a lot to do with Python. It has more to do with me. And I agree, and that's a little narcissistic. So instead, let's talk about my parents. So in my parents' day, not that they're old or anything, of course. In my parents' day, I like to say that they saw a lot more paper than I do. So my dad was studying engineering, and my mom was studying economics. And they didn't have the things that people my age do when we go to university. So things like online assignments, online lecture notes, and online textbooks. All of these things had to be put onto paper. And maybe if they were born earlier, they would have had to deal with things like these horrible tables of logarithms. So now I've never seen one of these in real life, but there is a paper object that's been around for centuries that actually did make its way into my childhood, and that's paper maps. So up until I was about 7, we would use this to navigate on road trips. And so whenever we'd go somewhere, we would have to twist and turn the map to match the direction that we were going. And if we wanted to find somewhere to eat along the way, we'd have to pre-plan it beforehand. So while this was happening, with the development of online maps like Google Maps, we started to see computers store and process all of this information. And soon after that, they shrunk to the size of mobile phones, and they could fit in our pockets. And now that I'm older, as someone who grew up sort of at the border of these two very different worlds, sometimes I'm struck by the absence of these physical items, like physical maps, that were all around me in my childhood. But I understand now that we have something that can do the job for us, and it can do it better than we can. So a mobile phone can figure out the optimal route to get to where you're going, and it could even suggest places to eat along the way. And if I take it up to more of an abstract level, I think this is why Python is so popular. So we love that it does so many things for us. And these are the menial tasks that we don't want to do ourselves, but which are necessary precursors to higher level tasks and decisions that you need humans for. Okay, so let's actually circle back to the point and take another look at the title of my talk. So there are two main concepts that I really want to highlight here. The two biggest words, I guess, ubiquity and operationalization. So I actually didn't know what this word, operationalization, meant until very recently. And by recently, I mean like after I submitted the title of my talk. So if you guys don't know it, that's totally cool. Here's a definition. It's a development, deployment, and evaluation of tools that are used internally. That are used internally within businesses to inform important decisions. So basically, if you're operationalizing something, you're making it a part of your business operations. And doing this with Python models involves using programs or software that are written in Python. And just another quick side note is that most of these models are typically machine learning models because, as we all know, that is one of Python's strong suits. So before we proceed further, I just want to make a really small but important distinction. So even if you use programming or use Python to solve a problem that you're having or to inform an important decision, doesn't mean that you're operationalizing it. So here's an example that shows what I mean by that. So say that we're a company and we have a very important decision to make, and we have a wealth of information that's available to us. So we go up to our data science team and we ask them to build us a tool that's going to help us make this decision. And they're all really smart, so they use the latest cutting edge research in machine learning. And they put together a really sophisticated tool that gives us our answer, and it gives us the correct answer. Okay, that's great. But let's fast forward a bit and say that there's another team within the same company that has a similar question as us. And they don't know that we've sort of already addressed this issue that they're having. Because our data scientists, it was sort of an ephemeral tool that they created. And moreover, even if they did know, maybe they have different information than we do. Maybe they've discovered more dimensions along which they can judge the situation to make a better decision. So they really have no choice but to go up to our data science team again and ask them again to build a tool. So what this means is that all of the effort and time that was put into developing our original tool is essentially wasted. And this is a net loss for the company of both time and energy, and that's something that we definitely don't want. So how do we do this better? If we ask our data scientists to create a flexible tool, and then we ask them to deploy it for visibility, and then we ask everyone who works on it or interacts with it in the future to make an improvement, then we can create something that only grows more and more robust and more useful as time goes on. So every single effort that's put toward it is actually not being wasted at all. And this is a net gain of both time and energy for the company, which we should always want. Now let's talk about ubiquity. So we're discussing the ubiquity of using these Python models. And typically, the people who create, design, and maintain these models are data scientists. So it's no secret that data scientists love Python. So this is a 2017 survey done by Kaggle. There were over 16,000 respondents, I think. And you can see that most of them love Python. So if we want to know who's using these Python-based models in their daily business operations, we should naturally take a look at what sorts of businesses love data scientists. So while I was researching this talk, I came across this 2018 O'Reilly study. And it basically gives us a snapshot of the state of machine learning in the corporate world. So obviously, since companies are at different stages of adopting these ML-assisted workflows, we need to split them up into 3 different categories. So O'Reilly has very helpfully done that and classified those who are exploring these ideas as having used them for 2 or fewer years. Early adopters have been using them for more than 2, but less than 5 years. And sophisticated adopters have been using it for 5 or more years. So we live in the information age, and that's characterized by the overwhelming wall of information that we're presented with on a daily basis. And on an individual level, this can seem chaotic and overwhelming. But on the scale of a business, even a really small one, it can quickly become insurmountable. So this necessitates that we rethink how we do business. And that, in turn, creates a demand for people who are familiar with these walls of data and people who are able to take these heaps of information and transform them into useful insights. And that's exactly the job description for a data scientist. And in fact, over half of the respondents had at least one person in their company whose dedicated job it was to be a data scientist. So if you're looking for a job, I would say go into data science. And if you do end up going into data science and you stay in that job for a long time, you might find that you have a lot more influence over the direction of the company as it goes on into the future. So for companies that are merely exploring the idea of using ML and data science and integrating those into their daily operations, you can see that product managers have over 200% of the influence that data science leads do when it comes to determining key metrics for project success. But for sophisticated adopters, so those who have been using it for 5 or more years, this number shrinks to 125%. And that puts data science leads on more of an equal footing with product managers. And if you're determining the key metrics for project success, you're essentially deciding which projects are worth investing time and energy into in the future. So this whole study is very interesting, and I really recommend that everyone checks it out. But one thing that it doesn't really talk about is the distribution of industries. So what kinds of businesses are actually using these types of models? And that's something that I'm going to address by talking about my inspiration for this topic. So in Plotly's Slack, we have a channel called Sales Feedback. And this is used by the salespeople of the company to basically signal when we have new leads, or signal when our customers aren't happy with our product, or hopefully when they are happy with our product. And I joined this channel a long time ago. I'm not sure why, because I'm a software engineer. And I haven't really remembered to leave it. So I just sort of ignore it. But after I found out that I'd be doing this talk, I was desperately looking for inspiration. So I decided to visit this channel. And immediately, I was completely awestruck by the sheer variety of industries and businesses that are using Python-based tools to assist their operations. And in particular, tools like our Dash framework. So who here has heard of Dash by Plotly? Great. So I'm going to show you a bunch of examples that do address sort of the distribution of industries. And all of them are actually going to be Dash apps. So for those of you in the audience who aren't really familiar with Dash, It's a web-based visualization tool. It was introduced to the world in 2017, and since then it has made its way onto the desks of many different mission-critical applications in many different industries. So Dash has a React.js front end and a Python Flask backend. So what this means is that although Dash apps have a web interface for the end user, they have a Python interface for the people who are creating them. And side note, recently we released Dash for R as well. That runs on a Fiery backend instead of Flask. But this is PyCon, so I digress. And we know that data scientists are already heavily using Python to put together these models and to use them, and even to present their data. But what Dash allows you to do is to project all of that information and all of those results onto a web interface that is interactive and reactive. So where does Dash fit into the operationalization workflow? Personally, I think it fits in everywhere. So to the right, you can see some parts of our Dash ecosystem. And each of them, you'll notice, hits one of the following: building an application, testing it, and deploying it. And if you'll recall, these are sort of the essential steps of operationalizing something, because you're continuously improving on things and deploying them for visibility. And if you're a data scientist, you can't always expect to send someone a Python file and get them to run it, or have them even know what Python is, or have them understand the results that you get. So something like Dash is really helpful. And for example, if you want to present your results in an important meeting, it's necessary to think about other things, like professionally, for making it look professional. And so the Dash ecosystem contains Dash Design Kit, which is used to do exactly that. Or if you're a company that's working with really sensitive data, then you have to also include authentication and authorization into your applications. And the Dash deployment server allows you to do that. So our goal really with Dash is to enable data scientists to translate the work that they do to people who are not maybe necessarily as literate in Python. So I'm going to go into a few examples, 3 specifically, that illustrate different use cases. So all of these examples are either actual apps that people are using, or they're proof of concept apps that we've developed for companies who are interested in using Dash. All right, so let's imagine that you're a clothing retailer, and you want to know which pieces and sizes to supply at each of your stores. So you approach your team of data scientists, and you ask them to create a tool. And they create one that's tailor-made to your specifications. And then they project it onto a Dash app, and then they deploy it. And now you have a way to see the data yourself, to interact with it, and to use it to make an important decision that you're going to have to make again and again. And since this is a web-based tool, if you host it on a server, it's not ephemeral. So it's going to be there for you whenever you need it to be. And it's going to speed up decisions that you need to make in the future in a reliable way. Or you can imagine that you're a delivery company, and you need to determine the best routes that are going to minimize your fuel consumption while still achieving your deliverables. So again, it's the same story. You go up to your data scientists, and then they put together some really sophisticated model for you, some really sophisticated solution. And then they put it into an application, and then deploy it. And suddenly you have a tool that does the work for you. And just like our maps that are in our mobile phones, it can even fit in your pocket if you want it to. Another benefit of this is, like I was saying, if you're a data scientist, you can't always send someone a Python file, even if they are also a data scientist, because that person is not necessarily sitting at their computer right now, and they're not able to run it. So I think it's safe to say that everyone really knows how to use the internet. So by hosting a tool like this online, you're able to quickly and effectively communicate your results, which of course is incredibly important. Let's go a bit more meta and say that you're a software company and you're looking to determine which products or which features need more engineering resources. So again, you go up to your data scientists or maybe just a couple of enthusiastic engineers who are going to do the work for free. And you approach them with this problem, and then they, again, put something together for you. And funny story about this particular example, this was actually created by someone at Plotly, one of our engineering team leads, in around like 2 hours on a Sunday evening. So we also have a need for this sort of tool. And now you have a dashboard, which is chock full of information, but really only the information that you need. So this is the precursor that I was talking about earlier, because you need this information to make a higher level decision. And it makes your job a whole lot easier. So it gives you a lot more time to spend on doing more important things. And here are some more quick examples. So if you visit our Dash gallery, you'll actually be able to look at all of these and play with them if you want. So say that you're a medical researcher and you're performing some sort of experiment, and you need to keep track of your patients' data as they progress through the experiment. So you can create a Dash app like this, and in real time, enter in your patient's data and apply whatever regression techniques you want. So instead of having these two separate steps where you collect the data and then you analyze the data, you're able to do both simultaneously. And this is going to speed up the rate of your experiment and speed up the rate at which you get results. And in fact, public health is something that I think we should all be very concerned about. So if you use something like this clinical analytics dashboard, you're able to see immediately where you might be falling behind in terms of patient care and experience. So this relates to sort of the monitoring part of operationalization. You're constantly evaluating where you're going wrong. And if you're able to keep this information updated, then you're able to tackle new problems before they even bubble up to the surface. So this app in particular is actually pretty special. So it's part of a Nature publication, and you can visit it online if you want to and play with it. The URL is right there. So even academia, even though it's not really a business, for some countries at least, it can also benefit, and it does benefit, from using these Python-based tools. So if you have an application like this, and you're doing work in bioinformatics, I don't know how many people here are in bioinformatics, but I've seen some of the data that you get from experiments in bioinformatics, and it's terrible. It's very, very ugly. It's a lot. And science is a field that's based in communication. So if you're able to use an app like this to effectively communicate your results and share them with the scientific world, you're making the whole process more efficient. And you're integrating Python into your operations as a researcher. So this is one of our more abstract applications. Support vector machines are used in regression and classification analysis. And I'm sure you guys all know that that's super important in many different fields. So sometimes these really abstract models are kind of difficult for us to understand. So if we have something like this that we can play with and mess around with, then we can hopefully develop a better intuitive understanding for how the model works, and then use that and apply that knowledge while we're creating our own models. And if you're thinking about this in a more pedagogical sense, if you use something like this in a college-level machine learning course, I think it would be super helpful because as a student, I personally loved seeing things like this where I was able to have a more tangible idea of the theories that we were studying. So I mentioned at the beginning that you can use these tools to help you make decisions. But as we all know, one of the greatest advantages of Python is that it's so flexible because there's such a huge world of modules. So with the right Python API, you can put something like this together where you're able to both view the information and act on it and make a decision in the same place. So for something that's as sensitive as trading currencies, as time-sensitive as trading currencies, you're able to save just that small amount of time that might make a huge difference. And if we go back to the literal meaning of lean manufacturing, we know that one of the key points of that is continuously monitoring your manufacturing process and analyzing where waste is being introduced into it. So you can even use Python to do something like that. So if a manufacturing plant wants, they can use Python to help implement this lean manufacturing principle. And here's something that's a little random. So not all companies can send an entire car into space, but as satellites and satellite-based technologies, as the cost of manufacturing them decreases, there are more and more companies, and it's becoming more and more prevalent in the corporate world to have these satellites and use them in some aspect of your product. So with something like this, you're able to track where your satellite is, you're able to track the health of your satellite, and if you wanted, you could extend this app and make it so that you're able to control it from home base as well. So there are countless more examples that I didn't put in here because of time. These are actually all of the industries, the latest industries that I've seen in our sales feedback channel. So if you could, please take a look at what's up here and raise your hand if you work in or near any of these industries. Yeah, so that's exactly what I'm saying, is that every industry and everyone has a need for this sort of tool and a need for this sort of technology. So I hope that you remembered to remember lean manufacturing. So let's talk about it a bit more. It was brought about as a result of the Industrial Revolution because we changed the way that we create products. And so we needed to think about what else should change. And right now, we're in a similar era of change, and it's called the information age. Except instead of thinking about how we create products, we're thinking about how we consume data. And we really need to conserve two incredibly important resources, the most important resources that we have, which are time and energy. And we need to cut out the waste in our processes that allow for these to escape. So I believe that humans and computers are very good at two very separate things. So computers, of course, have incredible processing power, but humans have the ability to take into account things like nuance and ethics, and to use things like intuition that have been developed for such a long time that computers aren't quite capable of understanding yet. So as both humans and computers continue to develop, and as more and more businesses start to implement these Python-based tools into their operations, we really need to think about the implications that it might have on the future. This field of data science, which is really the powerhouse behind operationalization, is growing so quickly that there's actually a deficit of data scientists around the world. So again, if you're looking for a job, go into data science. And the cutting edge machine learning research that happens as a result of all of these businesses enables us to extract really valuable insights from essentially faceless data. And that enables us to change the way that we think about how we create things, how we market them, and the design decisions that we make. And moreover, the demand for this research is actually fueling a lot of incredible developments in the field. And even though I'm an engineer, I'm a scientist at heart. So I'm always very happy to see more science occurring. I've also noticed that more and more universities around the world are actually offering pure data science programs. So these programs are designed to create professionals who are highly trained in this very specific but very necessary thing. But even better than that, I've noticed that a lot of universities are offering introductory data science and data literacy courses. And I think that's so important because we need to know how data can be manipulated to push an agenda, to misinform us, or to just say something that's not correct. And here's something else that I hadn't really given a lot of thought to. So as companies train and use machine learning models to help them make better decisions, they can draw attention to the inherent biases that are in some of these models. So computers, of course, are completely objective, but humans aren't. And humans have very tiny biases and tiny preconceptions that when we feed thousands of examples into a machine learning model, those get really amplified. And so here's another graph from the O'Reilly study. And I think the biggest difference here is in fairness and bias, which becomes more and more important the longer that you've spent working with these models. And if we're able to shine a spotlight on fairness and bias, then we're able to make the necessary corrections that we should to lead to a more equitable world. So on that note, let's talk about what we learned today. We learned that, first of all, virtually every industry can benefit from integrating tools like Python into their operations, because these tools do the job for us, and they do it better than we can. And this is exactly why so many different industries and businesses have done exactly that. And we also learned that procrastination can be productive, because in the process of writing this talk, I've ensured that I'm going home to a very clean kitchen, a nice warm pair of mittens, and hopefully the nightmares about losing my voice are going to stop now. So I'd like to give a few thank yous. First of all, to Plotly and, of course, the organizers at PyCon Sweden for giving me such an incredible opportunity to connect with so many brilliant and enthusiastic people, and to continue learning and growing both personally and professionally. And I think that everyone loves a chance to speak and to be heard. So I'd also like to thank all of you for your time and attention, and for making me have an incredible first experience in Sweden and first PyCon. So that's all I have for you. I can take any questions if you have any. Yep. How does Plotly compare to what?
Plotly compared to SciSets.
SciSets? I'm actually not too familiar with what exactly SciSets is, but if you come and talk to me after, then I'd love to chat about it with you. Yeah. Yep.
Okay. Hi. What would you consider should be the first step to take if you want to drastically change careers and start with data science?
That's a really good question. I think that right now we have such an incredible wealth of like online resources that we can use to teach ourselves these things, and they're really accessible. So I would say maybe if you have the time after work to start looking into doing that and start practicing, and maybe looking into getting some certifications as well. And then I'm sure you'd be able to more easily transition into a career that involves data science.
Answering your question, it's like in a data science, you can come from 4 different areas. You can come from statistics and mathematics, from developing, from business, or from from developing. So it's 4 different sides. So it's depending what is your background, you would need different skills. So if you're a programmer right now, you probably can go and take some statistical courses and start to understand statistics if you haven't done this in your previous education, and learn a little bit about communication skills, presentation skills, because how to do the graph and communicate with the end user will be very important. But this is a good question, and I think this will be part of the discussion, of a panel discussion about Python teaching, because Python is also part of data science. So I think they will raise this question, and you will be able to ask this once again.
Thank you for your talk. If you wanted to take a group of high school students, say 12, 13-year-olds, that are actually very keen on these types of things, through a worked example or a tutorial on a worthy cause, I don't know, climate change or something, are there any examples or tutorials that, we could look at first and then take them through?
Yeah, so that's a great question. And I actually have a younger brother who's 15 right now, so I'm trying to get him interested in this sort of thing as well. Like I said, nothing right off the top of my head right now, but if you give me some time, then I can probably definitely come up with something that would interest them.
Hi, thank you for your talk. I have a question about like Plotly and Dash, and how do you, what do you see as the strength of Dash and Plotly compared to all like the plethora of tools that are out there for data visualization, especially in comparison to, I mean, maybe more like fine-grained programming tools like D3, or in the other direction like Tableau and Power BI and like the kind of WYSIWYG.
Yeah.
Like data visualization tools. Where do you stand out in kind of that crowd?
Sure. So I think that there's always a trade-off, especially in software, between being able to abstract something more and so be able to do things quicker versus being able to get exactly what you want. And I think that Dash sort of hits that sweet spot in the middle where it is easy to use because, like I said, Python is a simple language. But at the same time, if you want to customize things, you're able to do so. So we actually have our plotly.py library, like I'm sure you know, a graphing library, but now we also have Plotly Express, which was launched this previous summer. And so that allows you to make more like one-line declarations of graphs that you can do while you're exploring data instead of maybe wanting to present it in an exact specific way. Does that answer your question? Okay. Okay. Thank you, guys.